Working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to look into the topic the stable managed problem under the design and analysis of algorithm for second year fourth semester Artificial Intelligence and Data Science students. Let's get into the topic. So what is stable managed problem? So the definition. So a stable managed problem states that for given n men, that is m men and women pairs whose members are selected from disjoint n element sets y and x in one-to-one fashion, that is each man can m from y is paired with exactly one woman w from x and also the vice versa. So a stable marriage problem states that given n men and n women, where each person has ranked all the members of the opposite sex in order to preference marry the men and women together such that there are no two people of opposite sex who could both rather than have each other than their current partners. If there are no such people, all the marriages are stable. So consider the following example. So let there be m1 and m2 and women 1 and women 2. Let m1's preference list will be w1 w2. Let's say m2's list of preference will be also a w1 w2. Let w1's list of preference be m1 m2 and m1 m for w2 also m1 m2. So the matching will be m1 w2 w1 m2 is not stable because m1 and w1 would prefer each other over their assigned partners. This matching is stable, that is m1 w1 and m2 w2 is stable because there are no two people of different pair are preferred each other over their assigned partners. So let us see with an example. So here the men's preference is given. So the men's are Bob, Jim and Tom, and the women's preference are Anne, Lee, Shu. So in the stable, that is Galley-Shapley, by using Galley-Shapley algorithm, so first of all we have to find the ranking matrix. So have to find the ranking matrix. So we have given the men's preference and the women's preference. So first thing we have to form the ranking matrix. So we can do this stable marriage problem either using men's optimal or women's optimal. We can take men's optimal as the solution and we can do the same way can be applied for women's optimal as well. So have to find the ranking matrix. So in the column wise you give Bob, Jim and Tom the boys preference or the men's preference, and for girls preference you give Anne, Leah and Shu as the row wise or the column wise. So here Bob, Jim and Tom is given row wise and Anne, Lee, Shu is given as the column wise matrices. So now, according to the stable managed problem, the first step is we have formed the ranking matrix. So the ranking matrix is for Bob and Anne, we have to check what is the ranking. So when you take men's preference Bob and see to Bob, what is the preference of Bob towards Anne? So this is the second choice. So in the ranking matrix the number should be 2, and again come with Anne to Bob. So in Anne to Bob, women's preference, the number is 3 for Bob. So it is 3. So the first row, first column Bob to Anne is ranked, that is 2, 3. I repeat, for Bob and Lee. So for Bob and Lee, in men's preference for Bob, Lee is his first preference, and for Lee, Bob is the second preference. So the number would be 1, 2. Same way for Shu, Bob is third preference and Shu is third preference to Bob. So it is 3, 3. For Jim for Jim and Anne, Jim's preference towards Anne is 3 and Anne's preference towards Jim is 1. So it is 3, 1. So in this manner the ranking matrix would be done. So let's see the algorithm. For input, a set of n men and a set of n women along with rankings of the women by each man and rankings of the men by each woman with no ties allowed in the rankings. Output, it is a stable marriage matching. Step 0, start with all the men and women being free. Step 1, While there are free men, arbitrarily select one of them and do the following. Proposal. The selected free man M proposes to W, the next woman on his preference list. And in the response, if W is free, she accepts the proposal to be matched with M. If she is not free, she compares M with her current mate. If she prefers M to him, she accepts M's proposal, making her former mate free. Otherwise, she simply rejects M's proposal, leaving M free. Return the set of n matched pairs. This is the algorithm for stable marriage problem. So first, let us go into the men's optimal thing. We have finished the ranking matrix. So Bob, the first preference is Lee. So Bob is proposed to Lee. So since Lee has not any other choice, or she does not have any other mate, former mate, so she accepts Bob's proposal. Now the next free men are Jim and Tom. So for Jim, the preference list, according to the men's preference list, it is Lee. So Jim proposes to Lee. So now what Lee will be doing? Lee will be rejecting Jim's proposal. So now again the free men is Jim and Tom. So since Lee has rejected his proposal, now Jim is going to propose his second preference, Shu. So now Shu, she does not have any other soulmate. So then now Shu accepts the Jim's proposal. Now the free man is Tom. So Tom proposes to Shu and Shu rejects, since she is already having the pair. So now free man is Tom. So Tom is again proposes to Lee. So now Lee replaces Bob with Tom. Now free man is Bob. So Bob is again producing a proposal to Anne. Now since Anne is free, Anne accepts Bob. So according to the stable marriage problem, for this problem, so for Bob the pair is Anne, for Jim it is Shu, and for Tom it is Lee. So this is the solution of the given stable marriage problem.